Every person who has ever lived has looked up and seen the exact same face of the moon. Pharaohs, farmers, sailors, children staring out a window. All of them watched one single hemisphere and never once the other. Whole cultures read shapes into it: a face, a rabbit, a figure carrying sticks. And for most of history, the half we could not see carried a name built on a mistake: the dark side. Here's the first surprise: that hidden half is not dark at all. Over a month, it catches just as much sunlight as the half we know, blazing under the very same sun. It's not hidden by shadow, but by emotion, a slow gravitational trick that keeps one face aimed at us while the other points away for good. So the real question was never about darkness, because there is none. The mystery is why the moon refuses to show us half of itself and what it has kept back there the whole time. The eerie name came from an older meaning of the word. Dark once meant unknown, unseen, out of reach, not lightless. The far side was dark the way an undiscovered continent sat dark on an old map. We simply kept the word long after the physics was clear, and the spooky version stuck. And the moon is doing all of this only 250,000 miles away, the closest world to us by a wide margin, the one object in the night sky we feel we know better than any other. And we don't. For all that certainty, the familiar moon has been showing us a stranger's profile the whole time. Start with the lock itself. Stranger than it sounds. The moon is not frozen in place. The moon spins, turning on its axis once for every loop around the Earth, a single rotation roughly every 27 days. Plenty of us assume that because we always see one face, the moon must not rotate at all. The opposite is true. A moon that stopped spinning would slowly show us every side. The only reason one hemisphere stays aimed at us is that the spin and the orbit are matched almost perfectly, like a dancer circling a partner while never breaking eye contact. That match was not luck. Billions of years ago, the moon spun far faster, and Earth's gravity kept hauling on the slight bulge in its shape, dragging on it like a brake pad. Across ages, that pull bled the spin away until the moon settled into lockstep with its orbit. Our planet quietly throttled the moon's rotation down and pinned one face toward us, where it has stayed ever since. Because of that, there is no permanent darkness out there at all. The whole moon rolls through day and night as it travels, each side baking in about 2 weeks of sunlight and then 2 weeks of black. The one thing the far side never gets is a view of us. Stand on the near side and Earth hangs in the sky always. Walk to the far side and Earth drops below the horizon and never rises. It would be one of the loneliest views imaginable. The same sun, the same wheeling stars, but the bright blue planet that has hung over every human night gone, sealed behind you for good. The lock is not even quite perfect, and that flaw hands us a small gift. The moon's orbit is slightly lopsided, so it speeds up and slows down as it goes, rocking gently from our point of view and tipping its edges into and out of view. That wobble lets us peer a little around the rim. Tallied over time, we can actually glimpse about 59% of the surface, not just half. The remaining 2/5 has never, in all of history, been visible from the ground to a single human being. And the whole arrangement is slipping. Every year, the moon drifts about 1.5 inches farther away, and in exchange, its pull stretches Earth's day a hair longer. The sky we were born under is not fixed. It is one slow frame in a film billions of years long. And the dance does not end with us. The same braking that first locked the moon to face us is very slowly working back on the Earth. Run the clock far enough forward, ages past anything anyone alive will see, and our own planet could wind up tidally locked to the moon in return. A single Earth day stretched to match an entire month, while the moon hanging frozen over one spot in the sky. For the entire span of recorded history, that hidden half stayed a blank page. No telescope on Earth could ever crane around the moon to look. Then in 1959, a small Soviet probe named Luna 3 did the impossible. The Soviets had already tried and failed twice, one craft sailing past the moon entirely, another smashing into it. The third looped behind, aimed a camera at the side no eyes had ever seen, and fired off 29 photographs of the back of our nearest neighbor. What happened next sounds almost handmade. The probe carried real photographic film. On board, it developed that film like a tiny flying darkroom, dried it, scanned the negatives, and slowly radioed the images home as it swung back toward Earth. The pictures that crawled in over the following days were grainy, streaked, little more than smudges. They were still enough to stop scientists cold. The far side was not a worn twin of the side we knew. The wide, dark patches, the smooth plains that shaped the face people see in a full moon were nearly all missing. In their place sprawled a crowded, battered wilderness of craters piled on craters, a place that looked alien even by the moon's own standards. The pictures were also a Cold War thunderclap. The Soviet Union had not just reached the moon, it had seen its secret face first, and it told the world. A few stung voices in the United States muttered that the images had to be fakes. They were not. And because the Soviets got there first, they won the right to name what they found, which is why even now much of the far side is labeled with the names of Russian scientists. America would not photograph that hemisphere until 1966, and no human laid eyes on it directly until 1968, when the crew of Apollo 8 rounded the moon and watched that secret landscape roll by beneath them. And we have only just gone back. More than half a century after Apollo 8, the four-person crew of Artemis 2 swept around the far side aboard the Orion capsule, the first people in generations to set eyes on that hidden ground in person. From close range, they picked out features no one had ever seen directly. Among them, the great bullseye of Oriental Basin near the moon's western limb. A face that had stayed private for all of history finally had living witnesses again. It would be easy to file this away as one side getting lucky and the other getting hammered by space rocks. The truth is deeper and far stranger than bad luck. The two halves of the moon are not just scratched up differently. They're built differently, straight down through the crust. And the reason may trace back to a second world that no longer exists. Stay with this, because whatever split the moon in two faces is still one of the sharpest mysteries hanging in our sky. Set the two hemispheres beside each other, and the divide is impossible to unsee. The near side we know is draped in Maria, sweeping dark plains of hardened lava that once welled up from inside and froze into smooth stone seas. They blanket roughly 31% of the near side. Turn to the far side, and those plains all but disappear, down to barely 1%. Almost no seas at all, just blinding, rugged highlands chewed up by craters from edge to edge. And the difference is not skin deep. When NASA's Grail mission mapped the moon's gravity in fine detail, it found the far side carries a noticeably thicker crust, a heavier shell of rock riding at higher elevation. The near side is thin and low, the far side is thick and high. One moon, two completely different builds, inside and out. Here's the twist most of us miss. The near side was not spared the bombardment. It caught the same store of impacts the far side did. The difference is that on the near side, floods of lava later rose and paved most of those old craters over, smoothing the wreckage into dark plains. The far side had no such resurfacing, so it kept every scar. We're not looking at one calm side and one battered side. We're looking at one face that erased its history and one face that never could. So why is one ball of rock so two-faced? A leading idea reaches back to the moon's violent birth, when it formed so close to a molten, glowing Earth that the two nearly touched. The near side roasted in that heat, while the far side stared into cold space, so the far side cooled and crusted over first, freezing in a thicker shell. At the same time, a brew of radioactive heat-trapping elements, nicknamed creep, ended up pooled on the near side, keeping it warm and violently alive for ages longer. That's why the lava seas filled in our half and almost nowhere else. Then there is the bolder idea. Some researchers think Earth once kept two moons, a large one and a smaller companion sharing its path. If the pair slowly drifted together and met in a gentle, low-speed collision, the little moon would not have blasted out a crater. It would have splattered and smeared across one hemisphere like a thick second coat of clay, heaping up the rugged highlands that crowd the far side now. We may be staring at the fused wreck of two moons, with the seam tucked away on the half we could never turn toward us. The rocks Chang'e 6 carried back from the far side are already rewriting the story. In the lab, the basalt dated to roughly 2.8 billion years old, proof the supposedly dead hemisphere was still erupting lava long after most had assumed it cooled for good. The samples also revealed a deep interior that is oddly dry and stripped of the radioactive heat-making elements that kept our side molten, and they even hint the moon's old magnetic field briefly flared back to life around then. Two faces, it turns out, that differ far below the surface, not only across it. The strangeness does not stop at the surface. Some of the far side's biggest secrets lie out of sight, and one or two of them have no business being there at all. Start with the Great Wound. The South Pole Aitken Basin runs about 1,600 miles across and drops some 8 miles down, the largest, deepest, and oldest impact crater known anywhere in the solar system. It was gouged out roughly 4 billion years ago by a blow hard enough to punch toward the base of the crust and heave material up from the moon's deep interior. The scar is so vast you could lay it across the United States coast to coast. And something is still down there. When NASA's Grail probes mapped the moon's gravity, they picked up a dense mass lurking more than 180 miles beneath the basin, heavy enough to drag the whole crater floor downward. Its weight runs into the quintillions of pounds, as if a slab of metal 5 times the size of Hawaii's Big Island had been lodged in the mantle. The leading explanation is unsettling in how simple it is. It may be the iron-nickel core of the asteroid that dug the basin, still stuck in the moon 4 billion years after the strike, like a bullet a body never managed to push out. Then there was the heat. Microwave readings of the far side turned up a patch near 2 craters called Compton and Belkovich, running about 18 degrees Fahrenheit warmer than the ground around it. The source looks like a buried slab of granite roughly 30 miles wide, the slow cooling root of a volcano that fell silent about 3.5 billion years ago. Granite like that is common on Earth, where water and shifting plates help brew it, and almost unheard of anywhere else in the solar system. A chunk of distinctly Earth-like rock still faintly warm, under the face of a world we keep calling dead. For most of the human story, the far side was simply useless to us, a place we could not even photograph. Now, it may be the most prized ground off the Earth entirely, for a reason that has nothing to do with what it is in the rock. It is quiet. Earth is screaming. Every phone, tower, and satellite floods the sky with a constant roar of radio noise. And our own atmosphere smears the faintest cosmic signals before they ever reach the ground. That shielded hemisphere is the one nearby place where the entire mass of the moon sits between a listener and that racket. Apollo crews felt it firsthand. Every time their craft swung behind the moon, all contact with Earth cut out. A stretch of total radio silence on the far side of the world. No signal from home gets through. It is the quietest sky we can realistically reach. That silence is a key to the deepest past there is. Buried in faint, ultra-long radio waves is a signal from the cosmic dark ages, the stretch of hundreds of millions of years after the Big Bang, but before the first star ever caught fire. Drowned out on Earth, that whisper might finally be heard from the far side. Listening from back there could let us tune into the universe from a time before it held a single point of light. This has already left the realm of dreaming. In 2019, China's Chang'e 4 became the first craft ever to set down gently on the far side. In 2024, its Chang'e 6 mission went a step further, scooping up rock and soil and flying the first far side samples in history back to Earth. And engineers are now drawing up something stranger yet. Robots stringing a wire mesh across a whole far side crater to form a radio dish half a mile wide, a giant ear laid against the quietest spot in the solar system to catch the first faint sound of the cosmos. The first small steps are underway. A compact NASA-backed radio experiment is sent to ride down to the far side aboard a commercial lander, a scout sent to prove that a quiet antenna can survive the brutal 2-week lunar night and still catch those ancient signals. If it works, the crater-spanning dish stops being a sketch and becomes the obvious next move. There's a quiet urgency to it too. That radio silence is fragile. As more landers, relays, and satellites crowd the moon, The very stillness that makes the far side priceless could be spoiled before we ever fully use it. For a brief window, we have a perfect silent listening post hanging over our heads, and we are only just learning how to use it. So the dark side was never dark, and it was never a dead, empty waste. It was only ever turned away, holding a thicker crust, a separate history, a slab of buried metal, and a pocket of earth-like rock still faintly warm. Perhaps the ghost of a vanished second moon, and now a doorway to the dawn of time itself. The most familiar light in our sky kept half of itself secret in plain view for every single night we ever spent thinking we knew it. The next clear night, look up and sit with this. Half of that bright face is turned away from you for life, and you're gazing across 250,000 miles of pure nothing just to reach the part you can see. That gap between us and the moon is only the first tiny step. The space past it runs so wide and so strangely, almost cruelly empty, that it forces a question all on its own. Why is space so horribly empty? That video is on your screen right now. Go find out.